So today we are going to take a deeper look at elimination. So we're still talking about elimination. Okay, very similar process to what we've been doing. But sometimes elimination won't work out as fancy and as nice and neat as it did when we looked at it previously. Okay, so let's say we are given something, for example, like negative 2x plus 15y equals negative 32. And 7x minus 5y equals 17. So we have a system, we have two variables, we have two equations, and we want to be able to solve for x and y. Probably don't want to solve these by graphing because solving is for y. We're going to get some weird fractions going on. Solving by substitution, solving, again, one of them for x or y isn't going to be super fun. So we do still have this nice, neat stacked look for elimination. The problem is that when we go to that step one to find a variable with a matching coefficient, we don't see that, right? The x's don't have the same number sitting in front, and the y's do not have the same number sitting in front. When that is the case, that doesn't mean we just throw up our hands and say that we're done. Instead, we are going to try and force elimination to happen. And this is something that I've been trying to sort of go back on multiple times throughout the trimester, is just talking about that idea that there are things we can do that create equivalent equations, right? And equivalent means it's the same thing, it just looks different. So if we were to look at this equation, we then want to ask ourselves, okay, is there a place that I could multiply and make them match? And here's what I mean by that. So if we look right here at these y's, on the bottom we have a 5 and on the top we have a 15. Those don't currently match, right? They're not the same number. However, if I were to multiply that 5 times 3, it would become a 15 and then it would match. Now, I can't just randomly multiply 5y times 3 and expect to get an answer. But what I can do is manipulate this bottom equation and create something that is equivalent that contains a 15y in it. And the way that I will do that is by multiplying the entire equation by 3, right? Because as long as I do it to every single side of the equal sign in every single location, the equation is the same, it just looks different. So my top equation is going to say negative 2x plus 15y equals negative 32, just like it did before. And on bottom, I'm multiplying everything times 3. So I'm going to take that 7 times 3, which gives me a 21x. I'm going to take that 5 times 3 minus 15y. And then I'm going to take that 17 times 3, which will give me a 51. Okay, and now I'm sort of going to ignore this stuff over here, and now I'm going to focus on this new system setup that I have. Okay, and now when I look for a matching coefficient, I definitely see that right here. And that top 15 is positive, and that bottom 15 is negative, which means I can go straight into adding these two things, and I can add straight down. So a negative 2 plus a 21 will give me a 19x. My y's cancel out. A negative 32 plus a 51 is going to also give me a 19. This is something I can solve. And I will get x equals 1. Now I have lots of options as to where I can plug this x back in. I can plug it into the original first equation, the original second equation here, or the second equation where we multiplied. Any of these are fair game. Okay, because again, it's an equivalent representation when we multiply by that 3. Now, I'm going to stick to one of the first ones before we multiplied because those numbers are smaller, and I'm going to plug them to the y right here. But it wouldn't matter if you went someplace else. So I'm plugging in for x, guys, not y. So going right here. 7 times 1 minus 5y equals 17. So 7 minus 5y equals 17. Minus 7. So I'll get y equals negative 2. And so my ordered pair, 1 comma negative 2, or x equals 1 and y equals negative 2. Okay, so let's take a look at another one so we can sort of see this. Again, it doesn't really get shorter, it only gets longer. So let's say we have 3x plus 2y equals 1, and 4x plus 3y equals -2. Okay, so nice, neat stack look. Probably want to go the route of elimination. If we look at our x's, that 3 and 4 does not match. If we look at the y's, the 2 and 3 do not match. Okay, so we're out of luck there. So then we want to see if we can multiply. Well, here's where we have to start thinking. And my students often say, Mrs. McKinney, how do you see that? Well, I just have to try. I just have to try with my multiples. So if I look here, right, is there anything I can multiply 3 by to get a 4? No. 4 by to get a 3? No. If I look here, 2, anything multiplied 2 by to get a 3? No. This doesn't work. Oh, so now we're in even more trouble. Okay, so if we can't just multiply one of them to make them match, then we are going to have to multiply both of them to make them match. And again, this is just sort of you choosing your preference. Okay, well, what one do we want to force and make match? Again, I don't know that there's necessarily a right answer. I'm going to choose the y's because 2 and 3 are just a little bit smaller than 3 and 4. And I'm going to try and make those match. Okay, so what's something that they both are a common factor of, which means I need to think of a number that 2 and 3 will both divide into individually. If you cannot think of a number, just multiply the two numbers together. But I hope we start thinking of 6, right? If you thought of 12, that's fine. You can pick other numbers. Okay, and so to get 2 to be a 6, I'll have to multiply this entire top equation by 3. And to get a 3 to be a 6, I'll have to multiply the entire bottom equation by 2. Now, before I start actually distributing, I want to try and help myself do the least amount of work possible. So my next thought is going to be, okay, are those y's the same sign or are they opposite signs? And those y's currently are the same sign. So if I multiply by a positive 3 and a positive 2, my new equations, they're still going to be the same sign. And then I'm just going to have to distribute a -1. Oh my gosh, that's a lot of work. Okay, so instead of doing that as an entirely different step, let's just go ahead and multiply by that -1 here at the same time. So you could put it on either the top or the bottom equation, but we've consistently been doing the bottom, so I'm just going to stick to that. Okay, so on top, I'm going to start distributing through. So 3 times 3 is a 9x. 3 times 2 is a 6y. 3 times 1 is a 3. Okay, now I'm going to do the bottom. -2 times 4 is a -8x. -2 times 3 is a -6y. -2 times -2 is a +4. You have to make sure you multiply all the way through. Okay, and also keep in mind your work could look very different than your neighbor. You could choose to multiply to different numbers. You could choose to make the x's match instead of the y's, but you could still be doing the correct work. Okay, so now I have matching coefficients right here on my y's, and they're the opposite sign, so I can go straight to adding. So 9x plus a -8x is a 1x. The y's cancel. 3 plus 4 is 7. I mean, I don't really need to divide by that 1, right? But x equals 7. We can plug in for either of the equations. On this one, I'm going to go over here to the original top just because it's slightly smaller numbers. So 3 times 7 plus 2y equals 1. So 21 plus 2y equals 1. It's a -20. We get y equals -10. So as an ordered pair, our answer would be 7, -10.